Okay. All right. What's your thought on that first problem there? What do you think we ought to be doing? We need to get a common base. And what base would you suggest, Bryce?
3.
Okay, that makes sense to me. 9 is 3 squared. And what about 127? 3 to the negative third. Remember, 1 over tells you got a negative exponent. So once the bases are the same, then I can solve my the exponent equation. So 14x plus 2 equals negative 6x. So it looks like 20x equals negative 2. Did you get negative 1/10 as your answer?
Yeah.
Real fun, is that good?
That's great.
Okay. All right, let's look at B, letter B. What are you going to do with this guy? You can't have those two logarithms on the left side of the equation, so they're going to go together. But before you put them together, you better deal with that too. So that's going to be plus the log base 9 of 16. Now you can put those logarithms together, and when they go together, they're going to go together as a multiplication, because that's a plus. If that were a minus, they'd go together as a division. So what am I going to have then when I put those together? 48x plus 32. And then I can set them equal to each other. So 47x equals negative 35. I got negative 35/47. And then, because this is a logarithm problem, I always have to be on the alert for domain issues, right? So this right here tells me whatever x I get has to be bigger than 3. Is that bigger than 3? No. If I stick that in here, won't this be a negative number? Can I take the logarithm of a negative number? Never. So how many answers does this problem have? None, not one. It's the only root turns out to be extraneous. All right, looks like C is kind of the same, except it's an inequality. Okay, so here we go. I'm going to put those two logarithms together. Would you be okay with that? And when I put them together, they're going to go together as a division. So 8x minus 2 over x plus 1 is less than the log base 4/6. Okay? Everybody okay? So now I can say 8x minus 2 over x plus 1 is less than 6. Now, review from unit 1, or maybe beginning of 2, I can't remember, somewhere along there. This is a good review problem. This is called a rational inequality. You cannot multiply both sides by x plus 1, because why? Why is that not legit? Because that's an inequality. And when I multiply in an inequality, it matters whether I'm multiplying by a positive or negative, right? Do I know if this is positive or negative? No. So instead, we did problems like this. This is good review. You've got to remember, in an inequality, you got to subtract the 6. In other words, you got to get a 0 over here. Then we'll get a common denominator so that we have one fraction. I want one fraction. less than 0. Because I have a 0 there, I'm going to be able to draw a number line and do a sign chart, right? Because it's all about positive and negative. So what's my denominator? X plus 1. What's my numerator? 8x minus 2 minus 6x minus 6. So what does all that amount to? 2x minus 8 over x plus 1. So here's my number line. What 0 comes from the numerator? 4? What 0 comes from the denominator? -1. So here's -1, here's 4. So now I'll do a sign chart. I need to be negative. So if I put in -2, I'm going to have a negative over a negative, which is not what I want. If I put in 0, I'll have a negative over a positive. That is what I want. And if I put in a 5, I'll have positive over positive. That isn't what I want. Now, we aren't done. Xander?
Just going back to the like that 8x minus 2 over x plus 1 is less than 6. If it was just 8x minus 2 like over 3, could you times
Yep,
the 3 to the
you
6?
can times by 3,
Okay,
no
just use the
problem with
x's in
that.
there.
As long as there's no variable.
Gotcha.
Alright, why am I not done? What do I have to remember in a logarithm problem every single time?
Can't be negative.
What does this tell me about x? This right here says x has to be what? Greater than or equal, not greater than or equal, greater than,
0.
no, well, 8x minus 2 has to be greater than 0, which means x is going to be greater than 1/4. And this says x has to be greater than -1. So both of those have to find their way into my number line. So that one's already covered. That one is already here, so I'm good with that. X has to be greater than 1/4. So here's 1/4, and x has to be greater than it. So what ultimately is the answer to the problem?
1/4 to 4.
Everything between 1/4 and 4.
And where did the 4 come from in the beginning? On the number line, where did the 4 come from?
What makes the numerator 0? Set that equal to 0.
I don't understand how, unlike the fourth step, that the one, how are you getting 8x minus 2 minus 6x minus 6? I don't
Okay,
get that.
8x minus 2 minus 6 times x.
Yeah, so where are we getting that? Why is it?
Because the common denominator, so that I can combine these two fractions.
Oh, you're just subtracting. Okay.
Yeah. Yeah. I have to put these together into one fraction so that I can draw a number line with the numerator and denominator. Okay? This problem is a minefield. Okay? Because you are going to want to multiply by x plus 1. You cannot. Then you are going to do all this and forget about checking these. They must be checked. Okay? So you might want to try that problem again on your own. Make sure you remember all the different pieces of it. All right, and then D. Okay, so it's another inequality, but this time it's an exponential. So what do you think we ought to do first? Subtract the 3. Okay? Divide by 5. Common base, and what do you want to use? 2. So 1, this is 2 to the first, so that's fine. This is 2 to the negative 2. Now, since the bases are the same, we can say this. Are you okay with that? So negative 4x plus 2 is greater than 1. Don't let me make an arithmetic mistake. So negative 4x is greater than negative 1. And x is less than 1/4. Now, do I have all that other crap to worry about that I did in my logarithm problem? Nope, because this is exponential and the domain of exponentials is all real, so we don't need to worry about that. So our answer, negative infinity. Number 2, write, I think that's an 8, log base 8 of x as a vertical dilation of log base 3 of x. In other words, your answer should be a number times log base 3 of x. That's what a vertical dilation is. A vertical dilation is a function multiplier, a number times the function. Okay, we did one of these yesterday. Who remembers what we did yesterday? Xander.
Didn't we, so if we want to do the, like, base of 3, didn't we, like, do, log 3x over log 8, or log 3, 8?
Exactly. So fundamentally, any logarithm can be rewritten, like this one, for example, can be rewritten as log x over log 8. Every time, always. Now, what base is this? 10. Well, I don't want 10, I want 3. Perfectly fine, I'll just put in 3. I can put in whatever base I want. So here's my log base 3 of x. What's my multiplier? 1 over the log base 3 of 8. So now it's written as a vertical dilation of the log base 3 of x. No calculator on tomorrow's quiz, so you can't figure this number out. You'll just have to stay like that. Use limits to describe the end behavior of this function. All right, so do whatever you want. I would suggest you do a quick little sketch. What's this thing gonna look like? So first of all, we have to remember, what does this basic regular logarithm look like? That basic regular logarithm looks like this, doesn't it? As long as that number is bigger than 1, this is what it's going to look like. Now, it's been shifted 5 to the right, so let me shift it over 5 to the right. So how's that? Is that okay with everybody? We good? Now, I've multiplied it by a negative number. So what is that going to do? Flip it. So now it's going to look like that. Would you agree that it's the red one? So now we're going to use limits to describe the end behavior. Now, keep in mind that basically end behavior is the limit as x approaches negative infinity and the limit as x approaches positive infinity. That's off the right side, off the left side of the page. That's end behavior. But with logarithms, they're problematic because of that domain stuff. We have to alter that a little bit. Can my logarithm go to negative infinity? No. What is the farthest to the left that particular one can go? 5. So we're going to change this. Instead of negative infinity, it's going to be 5. From the right. It's coming from the right toward 5. And the limit is positive infinity. Now, can it go all the way to the right?
Yeah.
Yep. And that limit is negative infinity. Is that all right with everybody? Okay. Find the inverse. All right, so we've got that, and we want to find the inverse. Okay, so again, back to 2, 8, 2, 9, whatever that was. How do we find an inverse? Flip x and y. So keep in mind, this is y. So I'm going to make this x equals 3 log base 8, y minus 2 plus 7. Whatever you are finding the inverse of, switch the x and the y. Now, we got to solve for y. So what should we do? Subtract the 7. And then divide by 3, either individually or as a chunk. This one I'll do as a chunk.
Why don't we move the 3 to become an exponent on the end of the y minus 2?
You can, but then ultimately you're going to have to be cube rooting it, which is raising it to the 1/3 power. So it's easier just to divide it by 3 right away. Remember, you put a 3 there, you're solving for y, you're going to have to keep rooting. So I'd rather just not. But you'd end up at the same spot. All right, what now? We have to unlog it, right? We have to log rule it. We're going to get rid of that logarithm. So we're going to have 8 to the x minus 7 over 3 power equal to y minus 2. Which means that my inverse, using correct inverse notation, my inverse will be 8 to the x minus 3 over 7 power plus 2. Right? So we started off with a logarithm. Our inverse was an exponential. So now I'm going to start with an exponential, and guess what? My inverse will be a logarithm. Here we go. So that's y so x equals -2, 5 to the y minus 1, minus 4. Switch your variables. Alright, now what? We're solving for y. So we will add the 4. Divide by -2, either as a chunk like I did over there, or you can do it individually. Doesn't matter. Whichever one you want to do makes no difference at all. Now what? I am going to have to take the logarithm of both sides. So here we go. I'm going to take the log base 5 of both sides. And why am I doing that? What is the benefit of doing log base 5? This is just going to become y minus 1. So my inverse, using my inverse notation, will be the log base 5 of -1/2 x minus 2 plus 1. Is that okay with everybody? All right, now we are doing a bunch of evaluates. Remember, there's no calculator, so all these are rigged problems. They're all easily doable. What do you think? It's just one. Very, very good. There's lots of different ways you can slice this. One is you can make this an exponent, so it's ln root e squared, which would just be ln e, and ln e is 1. Yep, perfect. How about b? 0. Guys, come on. We talked about this ad nauseum. 6 to what power is going to give you 1? There's only one thing you can raise 6 to and end up with 1, and that is 0. So the answer is 0. All right, how about log base 1/7 of 49? -2, I heard?
Yeah.
Because if you raise 1/7 to the -2nd, you get 49, because it flips over and squares. Beautiful. How about D? No solution. Can you take the logarithm of a negative number? No, 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 never, ever, ever. All right, what about E? 3. What's the log base 7 of 7? 1. What's the log base E of E? 1. What's the log base 5 of 5? 1. So you have log base 7 of 7, 1 times 3. So that would be 3. Log of 100, no, 1/100. Log of 1/100. -2. So again, remember, the base on LOG is 10. So most of you can intuitively see that. You can always log roll it. 10 to what power is 1/100? That would be -2. To get 1/2. Log base 16 of 8. I I heard somebody already said the answer, but for those of you that are wondering, 16 to what power is 8? That's what we're doing. Can I get a common base here?
Yes.
So 2 to the 4th equals 2 to the 3rd. So 4x equals 3, and I heard 8 3/4 from somebody, and that is exactly right. H. It is -4. Yeah.
Wow.
We don't need to be struggling with this. Couple different ways you can think about it. You could take that guy and move him up with that exponent and have e to the -4th. What's the log base e of e to the -4th? Guys, that's a property. You need to know that the log base b of e to the x is x. Okay, how about I? No solution. Can you take the logarithm of 0? No, because what happens at 0? You got an asymptote. Domain is bigger than 0, not 0, so there's no solution to I. And what about J? -6. Log base 3 of 3 cubed is 3 times -2 would be -6. Very good. All right. Finally, consider this. What is the all this stuff about this? So let's get a picture of this now. Okay, tell me what you know about this picture. Just do a quick sketch. Xander?
Oh, we know it's gonna have to be moved over left 3.
So we know the asymptote that's normally the y-axis is now going to be at -3. Perfect.
Isn't it, decreasing because the one, 2/3, 2/3.
It's
2/3.
decreasing because that is less than 1. Remember that having a base less than 1 on your logarithm has the same impact as multiplying it by a negative. Okay? So, the original logarithm, the basic old logarithm, looks like this. We have not only flipped this over, but we've shifted it 3 units to the left. So where is my x-intercept now? My x-intercept is now at -2, isn't it? Where was it originally? At 1? Move 3 this way, puts it at -2. So here's what my picture looks like. So you already said it was decreasing, so this is decreasing. You already said its asymptote is at x equals -3. How about concavity? Concave up. X-intercept we have identified. What about domain? What's the domain of this guy? -3 to infinity. Perfect. Some of you are putting closed intervals in there. Guys, what's happening at -3? There's an asymptote. Can't touch it. Can't touch it. All right, and how about my range? -infinity to infinity. And how about my end behavior? Anytime I do end behavior, I think about x approaching negative infinity and x approaching positive infinity. But when I do a logarithm, I have to modify that. So what am I approaching on the left? Negative 3. So that negative infinity is going to be a negative 3. I'm still coming at it on the right side, on the positive side, but I'm approaching negative 3. Okay, so what's happening as I approach negative 3? Positive infinity. And what's happening as I go off the page this way? Negative. Okay, so having done that, a little bit of a review, you tell me on the review sheet I gave you yesterday, or a homework problem that I turned back and you're not sure why you missed it, anything that you want to talk about. Kennedy,
On 2.12, 2A.
homework 212, which problem? 2A. This is expand. We're expanding a logarithm, single logarithm. We're going to expand it out. So we have the log base 6 of 36W over Z. Okay, so my hope is that your first step was to either physically write down or at least think about the log of 36, or log base 6 of 36, plus the log base 6 of W, minus the log base 6 of Z cubed. Now, you don't necessarily have to write that step down, but does that make sense to you? Okay? Now, here is where a bunch of you just kind of skated on by. What's the log base 6 of 36? 2. This is 2. Plus the log base 6 of W minus 3 log base 6 of Z. So that is your simplified expansion. Okay? Same thing, B. B is the same thing. The whole thing is being cube rooted. So what power is a cube root? So we have 10p squared to the 1/3. So I'm going to pull that 1/3 out in front. So I have 1/3 the log of 10p squared. So that's 1/3, okay, the log of 10 plus the log of p squared. You still with me? What's the log of 10? 1. So this is 1/3, 1 plus 2 log p. So that's 1/3 plus 2/3 log p. Okay, Raina? All right, anybody else? Any question from a review sheet, a homework, whatever? Xander?
Might as well just go C up here too, because it's on 2.12.
All right, so that's ln 5 minus ln 3e to the 17th. So that's ln 5 minus, okay, this is going to be ln 3 plus ln e to the 17th. These are being multiplied, so I'm going to go ahead and make it an addition, but it's all being subtracted. So that will be ln 5 minus ln 3 minus ln e to the 17th.
Does the 17 just stay on the X of the year, just go before the
Doesn't really matter because this
Okay.
is an ln. What's ln e to the 17th?
17?
17. If you put it it out in front, it's gonna be 17 LNE. Well, LNE is 1, so that's gonna be 17. All right, what else? Josie?
You do 6 on that same
6. We're converting this into a natural logarithm. I may have marked some of these wrong. There's a couple different ways this could be written, so let's just see what you got. So our function is 3. Is that, I got something written there, I can't read. Is it not just log x? Okay. All right, and I'm gonna write that as a natural logarithm. So this is kind of like what we did before. This is base 10. So this can always be written as log x over log 10. That can always be written that way. Okay? And I got 3 of those. And I don't want any generic base. I want E, so I'm going to make these E's. So 3 ln x over ln 10. So if that's what you have, remember log base E is ln. If that's what you have, okay. You could also have put this 3 as an exponent up here and have ln x cubed over ln 10. Some of you, I think, put ln 10 into your calculator and got some decimal, so I may have marked that wrong. So if this is what you did, you are right. You are right.
On 210, we do 10 on
210, which one?
10.
Number 10.
Yeah.
So I use the graphs to approximate the following values. Okay, so I gotta use my graph up there, and I'm finding the log base B of 3 halves. So I have to look at the graph that involves base B, so that would be the G graph. So it's number 6, in other words. And I want to look where x is 1.5. That 3 halves is my x value. So on my graph, if x is 1.5, my y value is approximately -1. Because the curve is going down. So here's 1, here's 2, 1.5, I'm about at -1. Now, you might have negative something else. I mean, as long as it's close, yeah, as we're judging it from our graph. All right, what else?
Can you do number 9 on this?
Number 9 looks at the same graph, and it says, let x be 4. So again, depending on how accurate your graph is, this is the y value you want. That's where x is 4, so that's the y value you want. Mine is about, I said -3.3. If you have -3.5 or something, that's fine too. If you have a positive number, you're clearly wrong, because we're down here in negative land. Okay, what else? Yeah.
On the 2.11 homework, can you do C?
2.11.
Yeah, 3C.
3C. All right, let's take a look at this and see what the corrections are. Find the domain and range. Okay, so let's take a look at. All right, let's look at this for a second. Now, first of all, it's a logarithm. And it has has a base of 10, so it's a normal log rate. So the normal picture would be this. Would everybody agree with that? Now, where is the new asymptote? Obviously, we shifted. We got some stuff going on in that parentheses. Where's the new asymptote going to be? Asymptote. Okay, in the original curve, guys, I'm not sure why we're struggling here. In the original equation, where does the asymptote go? The asymptote goes where the thing you're logging is 0. So where is the asymptote going to go? At 2. So we have an asymptote at x equals 2. If you plug 2 in, what are you taking the log of? 0? Can you do that? No. Furthermore, whatever you take the log of has to be positive. So there's 2 ways you can think about this. One way is, what happens if you let x be 3? What if we're over here on the right side of the asymptote? What happens here? It's negative. Can't be over there. That must mean it's over here. Can x be 1? Yep, and in fact, if x is 1, you're taking the log of 1, which is 0. So there's my intercept. It's that picture. It looks like this. Now, why has it been basically reflected? Because x has been made negative. And what happens when you change the sign on x? You flip this way, right? So here we go. This is it. This is a picture of that. So I want to know the domain and range of this. Okay, so tell me about my x's. You didn't really need a picture to do this, but I think a picture helps sometimes. What's my domain? What are my x's? Negative infinity to negative 2. Or positive 2, sorry. Negative infinity to 2. And what's my range? Negative infinity to positive infinity. Emily, does that make sense? Or Olivia? That's Emily. Too many vowels in it, though. All right, what else? What else? Homework, review sheet, 2:9 to 2:13. Jacob, is your hand up? 2:11 to 4:10. So this is one of these. Oh no. I know what this is. This is logarithmic. So, what does it mean? What does it mean to be logarithmic? What does it mean in terms of my table values if I'm logarithmic? These are being multiplied, so these are changing multiplicatively, and these are changing additively, right? So let's look over here. Now wait a second. If these are changing multiplicatively, if that's 3 and that's 6, then what does this one have to be? Doesn't that have to be 12? And if 3k is 12, then k has to be 4. And was that my job? Find k? Yeah. Okay. All right, what else? 210, number 12. And those answers are full of ways to keep staying there. The volume of the water matter, is increasing at 0.08 feet per hour. So if I let T be hours, I guess I'm going to do it. If I let T be hours, then the height is 0.08 T. Does that make sense to you? Okay? So, if the height is 0.08 T, then my volume is going to be 225 pi times 0.08 T. And it says what happens at 5 hours. So I'm just going to put a 5 right in here. And I'm going to work that out, and that's going to be my answer. That's like a composite function where you have your height that you're building into your volume. All right, let's do one more. One more, guys. From somewhere. Anything from the review sheet? Our quiz will not take all period, so please, you're going to have to work through it. Remember, I did that review in less than half the period. So you need to practice, because you're not going to be able to just sit there and stew about it, because we're not going to take all period to do it. Who said something to me?
The quiz, about that way.
It's no calculator. It's problems like on